How are we doing, everybody? Nice. My name's Oisín Kyne. I'm CTO and co-founder at Obol, and I'm going to do you a slight mercy today and not spend all of my time talking about staking. I'm going to talk about the work we do underneath staking, and particularly our new product we're releasing called the Obol Stack. But before we get into it, I wanted to talk a little bit about what Ethereum is for. Most of you are in the space for quite a long time and remember when Ethereum was a world computer and it was here to disintermediate all of the men in the middle, and it was going to be something where it's not your keys, not your crypto. If you don't run your own node, it doesn't count. And that's what a lot of us kind of really believe in and why a lot of us run our own nodes. However, over the years that I've been in the space, things have kind of gone a bit away from that kind of goal. And the title of this talk is Self-Sovereignty and a World of Service Providers. And to give people a bit of an idea as to what that's like, I'm going to walk through an example of, one dApp transaction, pretty much the kind of hello world of using something in DeFi. So let's say you're using a decentralized application, and this is all an example. Don't take any one in particular for take too much heed of it. But first, you have your app. It loads from something like Cloudflare, Versal, GitHub, somewhere nice and centralized. Bad start. Then if you want to pull any history, you are probably not running a full node, or a full node alone isn't enough. You need an archive node, but an archive node is not really enough. You also need this thing called an indexer, and most of the time it's very hard to run an indexer, so you end up using a centralized service who will run this indexer for you. And funnily enough, between making this slide and giving this presentation, Alchemy have decided to sunset their indexer, so my slide is already stale because of a centralized company. Bad start. Then you have your smart contracts. Smart contracts, decentralized, great, no editability, all good. However, they often need prices. Prices aren't usually available on chain, at least not if you want to run the risk of getting flash loan attacked. So you often need to use a third-party system, hopefully not a centralized one, that will put the price on chain for you. These are usually called oracles, and these are another person in the middle, give or take. Okay, so far, so not so great. Next, you want to connect your wallet. Your wallet also needs to talk to the blockchain. We are not where we really need to be in terms of light clients or running wallets in your browser. Most of them, or at least MetaMask, the most popular, relies on something like Infura. Infura is deciding, what the blockchain is and whether or not you can use it. So still not really going the direction you need. Second, last, Infura has prepared a transaction for you, click sign. It's not really safe to go and put it on chain through the mempool. You might get sandwich attacked, people might take your money off of you, so you need to go through another party to get safely on chain. You have things like Titan, you have things like Flashbots, some of them more decentralized than others, but still another intermediary. And last but not least, you've sent your transaction, you've used your dApp, all good, you go to Etherscan to figure out whether it actually happened or not. So this is not really what we like to see in terms of don't trust, verify. And this is what I mean when I'm talking about reclaiming self-sovereignty in a world of service providers. So I mentioned that this talk is about the Obol Stack, and I wanted to start with give an example of how the Obol Stack differs from what I just walked through before getting into the technical side. So I call the Obol Stack a self-sovereign interface for Ethereum. This is a way for you to use Ethereum as, our Lord and Savior Vitalik intended, where you run your own node and you run all your own infra. Firstly, it comes with a local interface. That interface shows you the health of your node, all of the usual, and it lets you change your wallet over to connect to your local RPC. Your local RPC is powered by the lovely team at ETH_PandaOps, who build these things called Helm charts that allow you to install any Ethereum node of all of your different client types, and it can run in a light client, or it can run in a full node if you have the disk and the performance for it. One thing that is kind of unavoidable is the MEV aspect. You do not want to get sandwiched. So we work with the Blink Labs team as an order flow provider service, where any transaction you are sending goes through them, makes it on chain, and any MEV your transaction may give off can get reimbursed to you. And last but not least, you use your own local node for verification. You look at a local block explorer, see the transaction is there, and you don't leak your IP to Etherscan. An example of the UI is over here. This is still a bit work in progress, but this is kind of the idea of what I mean about the goal of a self-sovereign interface for Ethereum. Now, if that's the idea, what about the execution? Many of you have run your own nodes. Many of you have used launchers built by people in this room. And I wanted to give an analogy of my journey when it comes to setting up nodes through Raptor engines. These are the SpaceX rockets, version 1, version 2, version 3. So I've been running a validator for quite a long time. And when I first got set up, I did what kind of a lot of people did, which is set up some of these systemd services, maybe using a cron job, stuff like that. It works, but it can often be quite complex, particularly if you want to run lots of services and you want them to connect to each other. Maybe sometimes they break. Trying to figure out what's going wrong. You're running commands, trying to get into the logs and trying to search through them. You need to be relatively able to know what you're doing to manage it all. That has been quite painful. When the merge rolled around and I wanted to add Mev Boost because Mev was a thing, I was like, okay, I'm going to swap over and I'm going to use a thing called Docker Compose. Docker Compose is a way to run containers. Containers are like mini computers, so each of your different services can run on their own. They don't conflict with each other. They're not supposed to fight with ports. A little bit easier said than done, but that's kind of the idea, and it makes it a little easier. However, as the years went by, my Docker Compose got super messy, and I'd see new cool things I'd want to run, and I'd be a bit lazy, and I wouldn't really want to crack out this file and start to add in an extra container, figure out all the flags, figure out what I need to connect to, and all of the above. So things like AVSs, things like Layer 2s, I was like, I want to run these, but I don't really want to figure out how. So the Obol stack is built on 2 new technologies, but my PowerPoint is not really working properly, but they're built on Kubernetes and Helm. Kubernetes, for those of you that don't know, is the software invented originally by Google, and it is what undergirds, it's what undergirds most of the internet around the world. So if you're running thousands of machines and you have hundreds of thousands of services on it, you need some orchestrator, as they call it, to run them all. This is particularly important if you have lots of different services. Maybe you have a database and an API and something to do with automation. You can kind of package all of these together and you can wrap them up in a bow in a thing called Helm. Helm you can think of as an app store framework for Kubernetes. You can just take one Helm chart and you can install it into your cluster. So the Obol stack is designed to be a foundation for everything. We want to grow the Ethereum economy. We first got started by securing the Ethereum economy with distributed validators, and now we're looking to grow it. We want all of you guys to be able to run extra Ethereum services on your own machines, not using some SaaS platform, and we've built the Obol stack to make that more doable. One of the key reasons that Kubernetes is really cool is it's very good at self-healing. When you set up an application that runs in Kubernetes, you set up what's called a health check. And this is how Kubernetes knows that your software is running and is happy. And it basically checks on you every few minutes and says, still good? And if your software says, yeah, all good, it keeps going. If you say, no, not good, or you stop answering, it kills you. And then maybe restarts you, and hopefully your machine gets going. One example of where this is useful, probably many of you have seen your beacon node or your consensus client lose peers. It drains to 0. You don't really find out. Your validator's offline. You fix it, and you have to resync for however long it took you to go fix it. With Kubernetes, it will start reporting as unhealthy, and after a few minutes of being unhealthy and not figuring out, it's okay, turn it off and back on again. Problem solved. So this self-healing capability is super important when it comes to making your life easy and running services without a lot of pain. Beyond that, the next step is to have a very nice base layer. And what I mean by that in this case is an L1. Everything we do and every software we run more or less all depends on an Ethereum L1 node. So when you set up the Obol stack, it'll either come with an Ethereum L1 Lite client or it'll come with an Ethereum L1 full node. As I mentioned, we use EthPandaOps' Helm charts, so you can pretty much just pick any ELCL combi you want, and Paratosh and Barnabas has done the hard work of making that work for me. This is what you need to run L2s, sequencers, RPCs, indexers, dApps, pretty much you name it. So that's really what the Obol stack aims to do. We want to make it possible for you guys to be able to run your favorite L2, to run your favorite AVS, to add more stuff to your machine. And we want to make it such that it's pretty much a one-line install to do, set and forget, Kubernetes handles it. You have a little UI to check on it, maybe an OBOL agent to keep an eye and help you debug anything that's going on. And if we can make that happen, and we can lower the friction of running apps, and we can lower the friction of releasing apps, meeting in the middle there is how we grow the Ethereum economy and how we get more people running stuff. The kind of prime example is today is hopefully the day that Aztec has undergone ignition, give or take. It was about 80 validators away from it earlier today. And we're partnering with Aztec to allow you to run a sequencer in the OBOL stack. My goal is to turn it on beside my validator on the stack. I was kind of planning on having a demo now where I had a kind of laptop set up, but that didn't really work. So there's meant to be a video here, and I'm not sure whether it's going to play. Let's find out. No. Great. But what this video was going to show you is in the top left, you're installing the OBOL stack in a one-liner. In the bottom left, it has a terminal interface called K9s, where you can watch it turn on all these applications. They go from red to blue, and they're all happy. And on the right-hand side, it was going to launch a user interface to show this all working. That's kind of the crux of the OBOL stack and the kind of base framework we're looking to build. The kind of people we want for the OBOL stack to serve is obviously the node operators. We want it to be useful for you guys, but also for anyone that's building infrastructure in the space, particularly dApp developers, layer 2s, people that are using rollups as a service. We want these people to be able to A, release apps to node operators, and B, get their own users running their own stuff. They shouldn't necessarily have to spend all of their money on Infura and on RPCs. They should be able to tweet out like, hey, Dimitri, will you run my RPC? And Dima will be like, sure, I'm going to install it, and we're off. And that's kind of like the dream, and this is my talk. Thank you very much for listening to me about self-sovereignty and reclaiming it.
We do have time for questions for Oisín.
Nervous mumble.
No, nothing to worry about. What OBOL stack has to do with OBOL DVT?
So I might give you an example. I built kind of the OBOL stack for OBOL DVT. For those of you that ever used our software, we first shipped a Docker Compose. It comes with an execution layer, consensus layer, distributed validator, and a validator. And that kind of worked. And then all of a sudden, we wanted to be able to swap clients. Swapping clients is a bit of a mess. You're writing scripts that work with Docker Compose. They're kind of fighting with one another. And people also came along and said, I want to add more clusters. And to add more clusters to Docker Compose gets a bit funky. You have extra files. You try and hide those extra files with something called a makefile. And it was getting really mixed up between Bash, Make, Docker Compose. And I was like, oh, this is not what I want. I was like, how can I make this a one-line install to add more stuff? And my background is as a DevOps. I used to work with Kubernetes professionally when I was in Consensus. And I was like, well, if we had Kubernetes and Helm, this would be a one-line install. So I kind of built OBOL stack for myself, to be honest.
Okay, cool. Can anyone run like vanilla validator with OBOL stack?
Absolutely. Paratosh has also built validator client Helm charts. You could install it with a one line. That's the plan.
Okay.
Obviously, I think CVs are better, but
Is it already there, or we need to add it manually?
The OBOL stack by default comes with the ETH-Panda Ops Helm chart repo and the OBOL Helm chart repo. So anything that Paratosh or we offer should be able to be installed, though this is alpha software and not everything may work as expected. And I would say I would be very welcome for some bug reports for certain things that don't behave straight out of the box.
Okay, and the final question, this beautiful UI that you've shown, is that a prototype or is that a thing that we already get?
The screenshot is a mock-up, but it is already there, and it actually looks prettier than the screenshot. You might have spotted that the Get logo had a Nethermind icon, and there were some issues with that mock-up. But yeah, no, it's there, it's real. You install it. My video would have shown it for real, but yeah, it's there.
Cool, thank you.
I got this question from YouTube, from Theo. He's asking, what are the hardware requirements, I guess, besides like running the regular software?
Yeah, so this version of Kubernetes uses K3s, which is designed to run on like ARM chips. So this should probably run on a Raspberry Pi. The running of an Ethereum full node in Raspberry Pi gets a little interesting, but You can also run it with a light client, which depends on an upstream server to like serve you data. But a light client means that you can't get fooled. It checks the exact consensus layer to make sure you're served real data. So yeah, you can run this on, I don't want to say anything, but a very, very lightweight machine. Though it will be nicer if you have a bit of a bigger machine. You can run more L2s, more L1s, and do more things if you have common hardware. This is not really built for enterprise or professionals. This is kind of targeting home operator to SME type of people. Basically, the people in this room.
Awesome. So you had mentioned Aztec and a few other things. What about for teams that don't already have a Helm chart but want to get integrated? How difficult is that integration process?
Yeah. So that came to mind when we were talking to certain people. Not everyone comes from a DevOps background. Not everyone has Helm charts. So we released a Helm chart called the OBOL app. It is designed to just take any Docker image and run it for you. So you can just come along with the Docker container and say, hey, OBOL install, OBOL app, give it this URL, and it will just run your Docker image. We can go a little further and also run like Node.js apps and like kind of static front ends, but that's a bit of a work in progress. If you want that, come find me and ask nicely.
All right, excellent. Time for just one last question.
Hi there. You were saying it's intended for the home operator. So it's all for like on one node intention rather than clusters?
If you know what you're doing with Kubernetes, I would love to run them on multiple nodes, but I know that that's going to be a little buggy for people that don't use it. But yeah, one of our developers in-house runs a little Raspberry Pi Kubernetes cluster, and this thing is supposed to work straight out of the box on a local cluster, but your mileage may vary.
So is that offering any isolation between the containers?
Just Kubernetes namespace-based isolation. You can control Kubernetes and really tie it down if you want, but yeah, by default it is your standard Kubernetes level of isolation.
Excellent. Okay, well that's time for it. So again, a big round of applause for Oisín.